From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 395, recorded live Thursday, October 24th, 2013. This episode of Hansel Minutes is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, makers of Gesture Pack, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with John Sheehan from Runscope about REST, JSON, and web services.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I'm talking to John Sheehan, CEO of Runscope. How's it going, sir?
It is going great. How are you?
Very good, very good. I was at a hackathon recently over in New York, and we were doing a bunch of RESTful web service stuff, and I think we were talking to Azure Web Services. And it was really interesting to see kind of the state of web service APIs, because the hackathon was sponsored by a bunch of different API providers, which is the first time I'd been to one where it was like that. And it was like, if you use this API in our hackathon, you could win this prize. And, so people would end up using the API, even though it didn't make any sense to their product, just to optimize for winning the gift at the end of the thing. And, the state of APIs was really dodgy. I mean, some of them were like the barrier to entry. Like, this is a thing. From my perspective, if I've got an API and I want people to use it, at least from a demo perspective, let me use curl or let me use a browser and get some data immediately so I feel like I've achieved something. But we had one API that required a whole OAuth handshake just to get Hello World working. Have you seen that happening in the third-party API space?
I mean, this is really common. So one of the things that I spent a couple years working at Twilio, if people are unfamiliar. And one of the things that we really, really harped on was that somebody should be able to get up and running and send their first text message within 5 minutes of hitting the website, right? Like, you should have a cut and paste example. That should be the first thing that you run into on the website, is something that you can just drop in, run, and prove to you that it works, right? It doesn't have to do anything specific. All it needs to do is within 5 minutes, prove that you can put your keys in the right place and that you can get an SMS generate within the first couple minutes. Yeah. And I think that's something that really made Twilio what it is that sort of attention to that first run experience. Now, there are far more API providers out there and infrastructure API providers out there. And I don't think a lot of them have put in, the same amount of effort on helping people get up and running as quickly as like Twilio and Stripe and SendGrid and some of these, better ones are. So, that whole hackathon model, that was actually one of the places where we would take our product and try to see how fast can people get started. And if they couldn't get started quickly, then we knew we had to, areas to improve on.
Yeah, I think that's definitely the thing that you want to optimize for. People got really frustrated, and only one of the 100 people in the room at this hackathon achieved anything with the OAuth one, because not only they felt like they had to go and learn OAuth, and trying to get that to work like at the curl command line level was just so frustrating, but they desperately needed it. I think it was like recipe data. It was food nutrition data. It was something that our app won't work without this data.
Right.
And like stuff like even mapping APIs, some of them required, so much yak shaving just to get Hello World working that it was so discouraging for the average, newbie.
Yeah, and you'll see smart API providers do something like automatically generate you an OAuth key for your account when you sign up, right? So like Twitter actually was the first one that I saw do this with OAuth 1, is when you went into the Twitter dev console, after you created an application, it would generate a set of keys for you for your personal account to be already authorized against that application. Well, right. Now all their examples can just drop those keys in and you're up and running. They don't have to tell you, you don't have to worry about the OAuth flow. You can, defer that until later when you actually need, a third party or another user to come along. But again, not a lot of API providers are doing this. GitHub does it. A couple other really good ones do it. We actually wrote a tool, because of this, because we were trying to work with APIs that didn't auto-generate, keys for you. We wrote an OAuth tool where you can just put in your app credentials and then it automatically handles the app flow for you and then kicks out the key at the end. So you can skip the whole process of setting up the web endpoints in order to get an OAuth key.
And where do I get that tool?
And that's at runscope.com/OAuth_tool. And it works for both OAuth 2 and OAuth 1.
That's cool. Is that linked somewhere from the homepage? That seems like a very useful thing to know about.
That is actually, sadly, not even properly linked in our documentation yet.
Okay, so you have a secret tool. So this is not a tool for the community. This is John wrote something and hid it.
Well, that was actually the first tool we released when we launched the company earlier this year. One of the things, again, we were testing out the product. We kept running into this OAuth problem. So we built that. It is linked from within the product. So if you sign up and you go to the editor and you need a key to make a request, then you get the link there.
See, that's useful. This is something I would have liked to have known a couple weeks ago because, man, we were suffering. The other thing that we were having trouble with was that, in the SOAP world, kind of before a lot of the current folks were, maybe when they were 10 years old, like 10 years ago, there was SOAP, and then there was always this argument between, is this a web service or is this just POX? POX, plain old XML. And everyone would say, we built a web services API. And they ended up just, you do a get, and I'll give you some structured text. I used to call it angle bracket delimited text.
Yeah.
You know what I mean? Like it looks like XML, but as soon as we switched to posting, though, man, curl broke down. I mean, it was just people were really struggling to put together any kind of a payload.
Right.
From the
and
command
like
line.
Anytime, like SOAP, uses request bodies to specify what data you want to get back. And when you start trying to do request bodies in curl, you either got to pipe in a file or you've got to, send in a long string that if the receiving host is like new line sensitive, which is actually does happen. It's not entirely crazy that, some receivers treat XML like text instead of like XML. But, curl gets really hairy when you're dealing with request bodies. That's for sure.
Yeah, absolutely. And encoding single quotes versus double quotes, new lines, it was really a challenge.
SOAP was great though in like Visual Studio or Eclipse, right? Where you had like this, enter a service URL, get a API client library, and now you're just calling it like any other code that was, on your system, right? And I think there's sort of that set the sort of expectations for Java and .NET developers about how web services should work, right? I should get this nice, rich API that is like, feels like the rest of my code. And it's just a method that I'm calling that happens to go over the wire, but that's really just an implementation detail. It could be code that is running within my own application. Mm-hmm. As the, as the more recent web services have gotten more popular over the last 5 years, the simple, so-called RESTful or, JSON over HTTP, simpler formats, simpler structures where all you really need is a simple HTTP client. Sort of that big, heavy SOAP style has really gone out of style, but this has allowed it's made it more accessible for more people to make more web service calls. And that's been actually compounded by, the increase in mobile app development. The more mobile apps there are, the more every mobile app that is interesting is talking to some backend service, typically over some form of API. Now, a lot of people actually don't call those APIs, even though that's technically how they're implemented. But backend services sort of really started to blossom the last couple of years as we needed to power our mobile apps with server data. The interesting thing from that is that a lot of people took those, mobile service backends are like, well, we're already providing data to our apps. Why don't we just use that in this other thing? Or why don't we use that to power our website now? And so the web services have really become the core of applications now and really the heartbeat or even the nervous system in a way, where all the interesting conversations are happening over API calls. And that's not just a mobile service anymore. Big companies are starting to do more and more of this, in a less SOA way, but more service driven. So like, SOA was very heavy, the sort of well-defined, and you had the service discovery and these heavy protocols. And you might have big monolith apps that still expose web points, but now you're getting companies that are doing a lot of smaller services and a lot of little services and then composing apps out of those smaller services internally.
Right. Yeah. I have found that, in large industry, in large enterprises, that I still see a lot of WS star, and I spent many, many years doing that. And I think it makes sense when you have, the complexities, but also the security of your WS security when you have like a mainframe talking to some back-end service that, we're moving money here. I don't think I would want to move money even over SSL and JSON. There's going to be some certificates and some serious some serious negotiations, for lack of another word, in the back end. But when we tried to present web services to the public, that's when I think SOA fell apart. SOA makes sense when this internal organization wants to talk to that one, or I want to talk to the Fed from my bank. But then we said, oh, well, that's great. I'll just give that same API and WSDL to John, who's one guy in a garage. And suddenly it's like, whoa, okay, I need a certificate, I need a headers, and I need da-da-da-da-da. And then that's where I think SOAP fell apart. So I like the idea of formalized, difficult to version, strongly typed services way, way, way in the back office, and lightweight dynamic languages and dynamic payloads in the front end.
Yeah, I mean, there's definitely a different set of requirements for, really sensitive data that's only moving internally, right? Like you need a more explicit, security contract, or you might use client certificates. You're not going to probably pass an API key in a URL, when you're talking back and forth within your company with sensitive financial data. You can do money over SSL and JSON though. I mean, like Stripe will let you PayPal, any of these companies will let you take, payment information, and you're essentially sending either a credit card token or a credit card number over SSL on JSON to them. Really? And they're completely PCI compliant. And, there's no problems there. They don't recommend that. They give you lots of ways to not do that, but they will accept that. It is possible, right?
Yeah,
so,
that's true.
But the smoothest paths, the pit of success is by collecting that credit card, on the client side, and then, just sending the token back. And so like when we take a payment, we never see someone's credit card number. We only see a token. So but it is possible to do that securely over SSL.
Right. When I was doing banking, we did similar things. We would never actually send the account number. Let's say I'm doing a money transfer. I would never send the account number over the wire. I would send an index, because the server side knows that the business checking is the third account. So I would say from account index 3 to account index 5, and then the transfer is completely relative to some knowledge that the backend found. So even if I intercepted that on the wire, I would only have a vague idea of what was happening. There's an article that you pointed me to at the ACM, the Association for Computing Machinery, that said that basically we are all building distributed systems now, which is funny because I remember 15, 20 years ago learning about there are distributed systems programmers, and then there's the rest of us. And then we blinked and everyone has to think about queue length and asynchrony and APIs and all the
cap
things.
theorem and
all these things that used to be really hard. Like distributed computing is a practice. When did this happen?
So this is, I think, ties in really big again with that mobile services push that happened. So that's really what the tipping point was for service consumption, I think, is when the number of APIs just grew exponentially once we started producing them for mobile services. And you have these, essentially dumb clients, right, that have maybe some logic over the data, but for the most part are shuttling data back and forth to a server in order to even be functional, that need to understand network reliability or, consistency of data when you're sending it in from all of these, sometimes disconnected clients, right? And, sync issues and that sort of stuff. And, this is something that previously, again, fell into that distributed systems, knowledge area. And regular Joe Schmo web developer like me, I still am pretty sure I don't even know what all three, terms of CAP stand for. Consistency, availability, and, popcorn for as long as, as far as I'm concerned. And, so, the services have come down to a new class of developer, right? Or have reached a new class of developer that weren't previously working on these types of problems. Yeah.
It's become Hello World is no longer console.writeline. It's, HTTP GET.
And a Twitter client.
I successfully spoke to that backend system. Now I've got my Hello World now. The concept has been proven is always me talking to one or more distributed systems. I think though that people put these things together. Like I'm writing a mobile app right now myself. I'm making JSON calls. I'm pulling RSS. I'm downloading MP3s. One of the things that I'm not putting in though, to be frank, is very good testing. I'm not really thinking about reliability at all. I mean, 99% of the time, these HTTP GETs just work. So service reliability, I have no retries in my code. I haven't thought about perf monitoring or dependency management.
Right. And like, this is pretty common. So I worked at If This Then That for a while, and they have 65 API integrations. They do like more than anybody that I knew of at the time. It turns out actually after I left, I went and talked to other customers and they're like, oh yeah, we have way more than that internally, within our big company or whatever. But, 65 felt like a lot of integrations at the time. And so we would start to see problems with service reliability, right? Like, how do we know that Twitter is up when we need to make a call to it when we want to execute somebody's recipe? Mm-hmm. And so for a long time, that was a problem for Twitter. Twitter was down a lot. And so these recipes would basically fail and people would get unexpected results. We actually didn't even know in a lot of cases how many calls were failing. Like, we didn't have a good system for monitoring that. Like, we were just dumping raw logs into like really rough graphing utilities, but there wasn't really a good way to know how our application was performing based on all the service calls it was making. Mm-hmm. And the total application experience is the sum of all of these service calls across in the entire application that makes IFT what it is. The other thing is that once something went wrong, we had to write more code than we had to actually handle the success logic for the error logic. We spent tons of time writing error handling and retry code and did that call happen, 15 minutes ago when it was on a different machine? And now that we're retrying it and a different queue workers picked it up, do we actually have a result for that that's still processing? Or if you get things like really long network timeout. So if Twitter, there used to be this problem where once a week at a specific time, the Twitter API would start responding very slowly. It wouldn't break. So everything would still work. It would just take 15 seconds for any given API call to respond. And now when you're used to like sub couple hundred milliseconds, going to 15 seconds is a huge jump. And it would lock up workers and it would tie up with tons of systems. And like, we had to write a lot of code just to handle that one specific case. It turned out to just like sort of resolve itself on Twitter's end, but spending a lot of time like even trying to figure out like what was the pattern there, or seeing what happened. In a traditional like performance management tool, you'd have a tool where you would pull up a dashboard and be like, oh, okay, we can see every Friday night at 11 p.m. we're getting slowness on the server, on this component within our application. We must have a race condition that's time based or something like that.
Yeah, that's a really interesting point that you make there. I'm going to stop you because I want to dig in a little bit more into that. You brought up the idea that, hey, it was really fast before, and then suddenly it became slow. I think that happens when you treat a web service like a database. If you're getting spoiled by 100 millisecond response times, you're like, oh yeah, it's a database. It returns JSON. It just happens to be 1,000 miles away.
Right. And more, we're building apps that don't touch databases. So like mobile apps, if they're talking over the web service, they may only have a local database as a cache, but not necessarily as their primary data store. In our product, I work on the front end web interface that everybody interacts with. And I haven't touched a database since, I don't know, January when we first started building the product. Everything that I do on that front end is completely abstracted away via services. Now we use 4 different types of databases based on, the right type of data store for the right type of data in different parts of the product. But I don't know a thing about Postgres. And so I don't even honestly know if I could make a call to Postgres in Python. But if you want to ask me how to make an HTTP call and like properly cache it and retry it and do all that stuff, I have that experience now and that knowledge, because that's really where, the highest level programmers need to spend their energy now, instead of working or dealing with database issues and understanding, database optimizations even.
Well, I like the rise of databases like Parse or Azure Mobile Services, where I can write a whole app, store session data, user information, log into Facebook, and do all the kinds of things I want to do. And I know that there's a database out there somewhere, but database as a service is cool. I mean, it's just like, yeah, give me that name value pair for this guy. I don't really care how you do it. Select star from whatever. Just get it to me.
Right.
Yeah, go ahead.
Yeah, those are really great services, and I think those really illustrate the point of like, you may build an app now and never, ever, ever see a database and only see HTTP calls. And before, you had tools that would tell you, hey, we could profile our app's calls to our database and see where they were slow, or see slow queries, or, see problems before they really became a problem. And with web services, we've sort of lost a lot of that visibility. I think the tools have really started lagging behind, the way developers are actually building applications these days, which is why we started this company. I mean, we wanted to build those tools. We wanted to basically restore visibility into people's applications from the app developer's perspective, and give them the tools to be able to spot problems before they became bigger issues or became, Yeah, that's really it. Before they became bigger issues. Restoring visibility is the bottom line there.
So let's talk about that, restoring visibility. And I was poking around in your blog, and I found a number of kind of little community projects that Runscope has made. And one of them is particularly interesting, I think. It's called Request Bin. It's requestb.in. Talk to me about this.
Yeah, so Request Bin was a project by a guy named Jeff Lindsay. He goes by Program Online. We worked together at Twilio, and he's the guy that coined the term webhooks. Like, he really formalized that really nebulous idea into a slightly less nebulous idea and gave it a term, which I think is part of why they became successful, is that term really caught on with webhooks. And what a webhook is, it's essentially a simple HTTP-based push notification. So when something happens on a remote service, make a request to a URL that I've told you about to let me know about it. So some examples of this, like Stripe uses this. Anytime a charge is processed, they will post you back to your URL and say, hey, this customer was charged this amount of money. Here's the fee we took from it. It was successful. It failed. You can handle different scenarios. Twilio uses this for incoming text messages or incoming phone numbers. When an incoming text message comes into your number, they will post to your URL and let you know that something has happened so that you can process that. So, after he coined the term webhooks, and started sort of evangelizing this idea, he made a bunch of small utilities for debugging them. So one of the problems with webhooks is that in most cases, when you build a public web endpoint, you're providing that to to a user or a human. So when you go to a website and you fill in a form, if there's an error, you can visually identify that there was some problem with that and adjust the data and send it again. Mm-hmm. Well, since webhooks are machine to machine, there's really no verification that the data was received properly or correctly, or even what the data was when it came in. So you have to add a lot of logging to that. And so Jeff came up with this idea of basically, he called it originally Postbin and then later Request Bin, which was a URL that would show you every request that was made to it, just the raw request input data that was made to that URL. So when you're building webhooks and you want to know what the remote provider is sending you, you can just send them that URL. They can make the webhook request, and then it shows up on that URL.
So let me see if I can understand that. So paraphrasing, I go to Request Bin and I say make a bin, and then it gives me a little unique, it says request bin / and then some number.
Yep.
That's my private thing. It's almost like paste bin or a gist, like a GitHub gist. And anything I post there, you're going to record for me, kind of like, it's like TiVo. You're going to let me see it. I can see it was 3 seconds. I just posted right now as we're talking here. I can see my forum post parameters. I can see my headers. So I could go over to GitHub or Azure or anyone that makes webhooks and force them to post to me. They don't care. They're just posting to an endpoint.
Right.
And this is my way of injecting myself into the process.
Right. And let me see the data they're sending me so I know how to handle that when I receive it. Mm-hmm. You'll see sites like GitHub will let you generate, they call them service hooks on GitHub, and they'll let you generate a fake service hook, right? So you can put a URL and you can go test service hook. And so, I've used that many times to see what GitHub was going to send me after a commit. And I wrote my app and, tested it against that sample data that they sent. And then I go switch it to, my live code, and I actually commit code and they send it and my app breaks, right? And it's okay, so there's some difference between the test data they sent me and actual real production data. So what I really want to be able to do is collect real production data from my real commits as they happen, and not this test data, just so that I can make sure that I'm looking for the right attributes, or that I'm not, parsing on a null value or whatever else. Mm-hmm. And so Request Bin is nice because you can just drop it in and then watch the actual traffic that's coming through on your webhooks.
So usually I find myself when I'm doing local development messing around with things like Postman for Chrome or using Fiddler. And Fiddler is a really great tool from a fat client perspective, or chubby client, as I like to say. My only problem with Fiddler, with all due respect to my friend Eric Lawrence, is it's ugly. If Fiddler would just be attractive, I would spend more time there. And I'm actually spending more time in Postman just because it's pretty. It's very bootstrappy. Mm-hmm. But with both of those, I struggle to get in between the two hooks, the two services that are talking. Now, years and years ago, there was a thing called SoapScope that was a proxy, and I would just set it up as a local proxy, and then suddenly I would be able to see what's going on. How does Runscope compare? Is it a capturing tool like Wireshark? So,
Postman is a great product, and so is Fiddler. We like both of those things. The thing that's different about Runscope is that we don't in like the Fiddler case, you sort of have to change like system proxies sometimes, or it does a lot of mucking with system networking stuff, right? It tries to like get in there at a really low level and then, watch everything that happens.
True.
And what we wanted to do is we wanted to be as low touch as possible, like as minimal configuration, and don't make you change, unrelated things in order to capture your traffic. We wanted to make the minimal amount of changes in order to see your traffic. So, we came up with this idea of like, a Runscope URL where you would take the API that you wanted to call, and you would basically take that original host name and stuff it into a subdomain. You kind of encode it into the subdomain. So instead of like api.twilio.com, you'd make the call to api-twilio-com-your-secret-key.runscope.net. And then what happens is that when you make that request to us, it hits us. We can see the request and response data. We know what original API you wanted to hit because you've encoded it into the subdomain there. And so then we pass it on to that original host name that you've sent us, and then capture the response and then send it back to you.
Okay, so rather than me going to foo.com and posting my data, I say foo-com
Yep.
dash
Your
my
secret
API key.
Yep.
Dot runscope. So I'm tunneling encoded into the URL itself. So it's like a proxy without any of the overhead of proxies. Like there is no actual HTTP proxy involved. I'm just letting you be an intermediary.
Right. I mean, the technical thing is it is as a reverse proxy, right? You're hitting one host name that gets distributed to another one and it comes back. We don't like calling it a proxy because proxy has a very specific term.
Yeah, it's an interceptor.
Right, an interceptor. But this method allows us to do a lot of interesting things. One, it allows us to capture SSL traffic without any issue, right? Because your SSL, when you do this, terminates against us. We can decrypt it. We can see it. We send it again upstream over SSL and back down. So it's SSL end to end, but we take that snapshot in the middle, which is trickier with proxies. So like if you use like a traditional proxy, you have to install a system level certificate, and it makes it very hard to work with SSL traffic. So
as long as I'm not validating the certificate as being my own, even SSL will work fine.
So you can validate it because it terminates against us. So because as far as your client knows, you only are ever making the request to our servers, and we have a valid wildcard certificate on runscope.net. So anything that is a subdomain of that is a valid certificate. And then on the upstream, we validate the certificate to make sure that it's also valid. So we're not like allowing you to like make valid SSL requests against invalid certificates. You can turn that off if for some reason you're using an API like a self-signed certificate or whatever, but by default, we validate SSL certificates upstream.
Okay.
So that's one really big benefit. Two, we don't need to know anything about the API ahead of time, right? So some other debugging services make you sort of register URLs so that you say, okay, when I want to call api.github.com, you go to their website, you type that in, and it gives you back like a new URL, and then you use that instead. And so now you can only make requests to URLs that you've sort of pre-registered. And we wanted to make it so that you didn't have to come back to the website when you wanted to use a new API. If you know how to make the special host names, the Runscope URLs, then you can attach your bucket key, as we call them, to any subdomain or any domain that you've stuffed into that subdomain, and then continue on your way and make those calls, and they'll show up in your web dashboard without having to pre-register anything.
So this might seem like a lot of concepts because we're talking very fast, but I think it gets back to what I think the root issue that a lot of programmers kind of missed out on. I don't think that younger programmers, and I don't mean age, I mean experience. If you've been programming the last 5 years or so, I think that the assumption that you know what's going on underneath HTTP is pretty much handled. Everyone uses curl or sniffs headers, but I've found that people who've been in the industry 10, 15 years, sometimes 20 years, have taken that for granted a lot. And a lot of times I'll get an email from someone that says, I don't really know what's going on. I posted to this endpoint and that didn't work. And it's like, well, the internet is not a black box. You can, like, I always like when I'm teaching classes to telnet to CNN.com.
Yeah. Yep.
And like force them to browse the web from telnet. Like that's how my father did it, and that's how I'm going to do it.
Right. And that's probably the best way to teach somebody how HTTP works, right? Is like, open that socket connection on port 80 and be like, all right, I'm going to type a version number. And now I'm going to say, hey, I want to open this URL, and like to see the text come streaming back. I think that's a really big light bulb moment for a lot of people.
Yeah.
And I think what you were saying about, more experienced programmers sort of taking some of this for granted is that, we've been really heavy on abstraction until recently. I think there's been sort of a pushback on abstraction recently, right? Like you see it in the ASP.NET area, right? Where we went to MVC, which was less abstraction, than the web API, which was even lower level, or the popularity of frameworks like Node, which were like, we were doing Rails the 5 years before that, which was this really heavy abstraction, like really opinionated abstraction. And now, Node is like, all right, you have a server. It returns,
right.
HTTP,
here's a socket.
Right?
Good luck. And a callback, right?
Right.
Have fun.
Exactly. I think we've seen some pushback on that. And so, trying to detach people's, mental weight of like these abstractions and say, hey, let's look at this at a lower level and like, let's get visibility at a lower level is something that's really gotten more popular in the past couple of years.
Yeah, definitely. I think it's unapologetically low level is what I like to say. And I like that aspect of Runscope. It has that kind of lightweight feeling of like a paste bin or a gist, but you're basically watching these calls happen. And you can share them with friends, give them unique URLs, comment on them. So it's almost the kind of thing you'd want integrated into GitHub if you were doing GitHub for web services.
Right. And what we wanted to do is we wanted to make them as tangible as anything else that you already are working with, right? So if you like are working in Visual Studio and you set a breakpoint and you pull up an object, you can like navigate all the way through that object hierarchy and you can see any piece of data. You can actually change data in flight, right? Which is just such a...
Why shouldn't you be able to?
Right. We kind of take that for granted when, it's code that is running within our apps and on our own machines. And so like we wanted to bring that same level of tangibility to HTTP requests since they are essentially method calls that happen to go over a wire.
Yeah, definitely. And I'm looking up here. It looks like, pricing, people can have 2,500 requests a month and 3 buckets for free. And it doesn't look like you want a credit card or anything to start with. So there's no reason not to, give it a try.
Yeah, everyone starts on like the full team plan for 30 days, no credit card. That like lets you exercise the entire product without restriction and make sure to see if it's going to work for you. If you don't do anything, you automatically get downgraded to free. Again, there's no obligations. And if you want to cancel, you can email me and I'll cancel your account anytime. But we've tried to make it, again, the barriers really low to like help you get in, solve your problem and get on your way. If you don't use Runscope every day, I'm okay with that. What we really want to do is like help you solve those one-off problems, like those really nagging HTTP calls that you couldn't solve any other way. Like we had a customer email in yesterday. It was like, we've been spinning for a week on this and before we found Runscope and we solved it in 3 minutes, right? And it's like, if you can't see it, you can't fix it. So that's really what we want to do is let you see stuff that you couldn't see before.
That's cool. Last question. How would I do this with localhost? What's my, I've got a local website talking to a local web service and I want Runscope to watch.
So that is more tricky, right? Since we can't obviously proxy local requests, we can't see those as well. We do have one solution that helps you sort of take your local host and expose it publicly and then along the way capture all the requests to it. So this is another Jeff Lindsay program project that he started out a couple years ago. He created something called Local Tunnel, which essentially temporarily opens up your local host on a public URL and then lets you make requests to it externally. So it does all the, tunneling and reverse proxying to make that possible through any firewall. This has become sort of a cottage industry. Actually, there's a bunch of them. One really good one is called ngrok, ngrok.com, which was made by another former Twilio engineer, which is essentially the same thing. It's introspectable local tunnels. We've built this into the product as well. So we call ours Passageway. And what it does is that you go into the command line, you say, open up port, 8000, and then it gives you a URL. Now, every request you make to that URL is forwarded to your local machine, but is actually captured along the way. So, this solves part of the local host problem. It doesn't solve for like, I'm running an app in a simulator and I'm testing my local service, and I want to see what's happening all on my machine. You would have to go out on the public internet at some point for us to be able to see it. Down the road, we'll address this problem more sufficiently and come up with ways so that you can, see your local traffic in Runscope without having it to go over the public internet. But that's still a little ways down the road. Right.
I mean, I could hear people, and I guess this is called Passageway, is what the word for this is.
Yep.
I could hear people who are into security saying, "Oh my goodness, suddenly my engineer has used perfectly public normal things like NAT and, appropriate technologies to completely bypass the security that my company's put in. Why couldn't you have a little tiny local proxy that just watches and then kind of sideways throws up to Runscope for inspection? So you're just throwing the traffic up without doing any fancy proxying.
That is a really great idea.
You like that? Can you get that written by the end of the day?
End of the day, probably not. But I think that's the exact kind of model that we're looking at for the future is, like, let us see not only just like local host traffic, but like intranet traffic, for lack of a better word. Like, let us see our internal traffic that never even goes out over the public internet. Let us get at the same level of visibility on that type of stuff too. So we're very interested in pursuing that in the future.
Very cool. All right. Well, thanks so much, John Sheehan, for chatting with me today.
Yeah, thanks for having me, Scott.
This has been another episode of Hansel Minutes, and I'll see you again next week.